to be talking at the Nordic Expo event. Thank you for the invitation. I'm a Chief Operating Officer of Swiss AI. We help our partners in implementing digital twins, not only representing today's status of the city or a system, but helping better plan and prepare for the future. We worked with such cities as St. Gallen, Zurich, Sarajevo, and with our partner Hitachi in various cities in Japan. We recognize how challenging it is for the cities to have a unified digital city system implemented. It involves combined data gathering and implementation of such a system. And even the questions which should be posed to such system are a challenge. Moreover, the tremendous number of potential solutions it can produce, the evolving nature of the challenge itself, the financial requirements needed for the infrastructural upgrade for mobility services, they all pose a significant challenge. We have a 13 years experience in this domain, so we can help rapidly and cost-effectively to create evolving digital twins. What evolving means is, well, first, the mobility infrastructure is planned for decades, and therefore one has to look at the future. For example, in Satsuma Sendai in Japan, the population drop and aging of the population will change the way mobility services will need to be provided. The mobility is also codependent on the city structure, so the new developments in urban planning, the new developments of high-rise buildings will all have an impact, and we model the way mobility services are provided, need of that provision under these different evolving constraints. The mobility also is highly linked with other evolving aspects, like demand change. So we include migration and behavioral change. For example, we modeled spread of COVID for the Swiss Army in the first wave, so that we could help allocation of resources like beds and doctors throughout the country. Finally, there are aspects of regulatory changes and technology adoption rates, which also have a big impact on how the system evolves. We include not just evolving nature of the system, but also other relevant aspects for mobility, like energy system, so we can help assessing codependencies and help optimize transition into e-mobility. Our whole system is financially underpinned, and therefore Swiss AI supports infrastructure investments as well as real-time market participation, for example, on-demand mobility services or energy market. Thank you.
And Hans, could you please also present yourself in a few minutes?
Yeah, thank you. I'm very happy to be part of the Nordic Edge conference as a Middle European. I'm head of ITS Vienna Region. ITS Vienna Region is a project organization part of the Public Transport Association of the Vienna Region. We are the competence center for traffic information and traffic management for the provinces Vienna, Lower Austria, and Burgenland. This is the eastern part of Austria, where almost half of the population of Austria lives. ITS Vienna Region was founded in 2006, and we work together with our three shareholders, Vienna, Lower Austria, and Burgenland, on real-time traffic information, traffic management, and we support traffic planning. We take part in our big national ITS initiatives and organizations, which is first of all the digital transport graph for all public authorities of Austria. It's GIP.at, where all the roads and even footpaths and public transport infrastructure is up to date. We collect real-time traffic information for road traffic in the project EVIS. We collect all public transport information in AGÖVV, and we are part of Traffic Information Austria that provides a white label traffic information service for more than 30 partner organizations in Austria. We are one of them.
Wow, thank you. Thank you for that introduction for both of you. Now, what I was hoping for is, Vanessa, that you can show maybe the response to the first, it was more of a word cloud we were asking participants, what is the first thing that they think of when they think of a digital twin for urban mobility? And these are some of the responses. The bigger the word is, that means the more it was mentioned. So it seems like the main thing that people think of is efficiency, meaning probably efficiency in providing mobility services, and then also data accessibility. The question that I have for you is, because we've been talking today about digital twin for urban mobility, what is the digital twin for urban mobility, or better yet, what is it not? And how is it different from the intelligent transport system, or is it different? Both of you, whoever is, whoever wants to answer can answer.
I can maybe say a few words.
Mm-hmm.
The issue is that the digital twin for mobility can mean different things to different people. Something as simple as collecting a digital database of special developments buildings, together with schedule of public transportation and statistical private transport model with perhaps some data gathered from sensors, could be called a digital twin. It's a typical digital twin, and often in what it does into future, it's relatively static. A more advanced digital twin accounts for how the city lives and how the city evolves. It accounts for what people do, their jobs, the city's economy, buildings, all the transport infrastructure combined, as well as the behavior of current and future inhabitants. So it's a dynamic, evolving digital twin. It's far more complex, but also represents better the reality of how the city can function and would function under the future scenarios, which could be, for example, technological change in mobility sector. It is more upfront effort to set up such a type of a digital twin, but it greatly reduces the work for the future analysis as it is integrated and allows the future projection. Maybe also I will say a few words on what it is not. Such typical digital twin cannot predict the shocks. As we say, it can model the impact of shocks, being black swan events like COVID. It can model the spread of that event, but it cannot model the likelihood of its occurrence. So we could see how the city and the transport system evolves in the future need for the services under the given scenario of the future. And then that all leads to the big word which participants chose, the efficiency, because one can, in an efficient way, model the future system and better plan for the most optimal solution for the inhabitants, and possibly investable solution.
Thank you, Anna. Maybe before we hear also the response from Hans, Vanessa, if you can please share the second question also in the chat so that people can answer the second question while we're answering the first one. Thank you. Oh, no, just the question so that people can answer it in the chat, not the responses. Yeah.
Yeah, I know. The question is, you can already see the question if you open.
They can already see the question
page.
using the same link.
Yes, it's the same link. Always use the same link or let it open. And then you can now answer the second question. All
right, thank you very much. Hans, please. So what is in your opinion then the digital twin of urban mobility? And since you're in ITS Vienna region, how is it different from, for example, system maybe that you had before, or ITS systems that cities have?
What I understand as a digital twin is a two-way communication between the real object and the virtual object. And that's a bit more than traditional ITS is, but it comes quite close. But let me suggest a wider view. Let me introduce more siblings. First, we have the physical reality. Let's say that's the stuff we can easily measure and that we can describe as parameters. And this stuff exists since 30 billion years. That's what we mostly focus on, but there's more. There are like biological life forms. They also have a two-way communication between the creatures and the environment. And they also have a prognosis about how the environment will be. So it's very similar, but it's maybe not so interesting for us. So let's skip that for now. Then we have the mental model of the environment, kind of reasoning and projecting. This exists since, let's say, 60 million years. And we have clearly a two-way interaction here. You know, you experience day by day that there is a clear two-way interaction and it's relevant. And then there is social organizations with a reasonable degree of freedom. We don't talk about ants here. And that exists since like 300,000 years. And the most important part for us are the normative rules. These social organizations, they get themselves normative rules. And all on top of this, like the fifth sibling, the youngest sibling, is now technical simulations with two-way interactions. That's what we talk about today. And they exist since maybe 40 years. Let's say 40 years. And what I want to stress here is they interact with all four other systems. Let me give you an example for clarification. Traffic lights do not stop cars. Traffic lights just show red, yellow, and green. That's it. Apart from cars and traffic lights, we need normative rules. The rule is we do not drive on red, and humans with mental models that decide not to drive on red. And I think it's very important in all these interaction circles between these various systems, not to forget humans, the mental maps of humans, and not to forget social organizations. And what we do today is mostly not influence stuff. We measure stuff, but we don't influence stuff so much. Maybe we influence lights, but we don't influence things that really happen. And the things that we really influence is people with real-time traffic management, and we influence organizations or norms with traffic planning. And I think it's very important not to forget that. That's what I wanted to say here.
So if we go from an ITS to a digital twin, what is the first step? What is the gap between the ITS and the digital twin? Is there a gap? Or is ITS a digital twin on its own for the mobility?
I think ITS, we do ITS since 2006, and this two-way communication was built in from the beginning. So in some way, the gap is not very big from what we understood as ITS in the beginning and what is now called digital twin. What I want to stress is that we have to see the more complex picture of organizations, of people, of mental maps, of various systems that make prognosis about the future and act upon it. And our digital twin is the youngest sibling of all this measuring, prognosing, acting parts.
Thank you, Hans. This sort of, and let's say, puts an accent on how complex the digital twin is and how it has to involve all these, let's say, dynamic inputs that are constantly changing and affecting how our forecast will be. So since the system is, let's say, so complex and it can be maybe also financially burdensome on the system, it brings me to my second question, which is, which we also ask the participant, and we also asked this on social media previously, which is what is the added value of having a digital twin for mobility? And some of the questions some of the answers that we provided there was improving quality of life of citizens by providing reliability and efficient transport options and other services. The second one is helping tackle climate change by being more sustainable and resource efficient. The third one is helping electrify the transport through better integration of EVs and charging infrastructure with the grid. Or the fourth one is informed and transparent urban mobility planning with easier stakeholder involvement. And Vanessa, if you can please share the responses. I know that previously on social media, some of the responses, the most responses, let's say, went to more sustainable mobility and then improving efficiency for users. Maybe I can see what we have right now. Vanessa, could you share the screen? Yeah, I see we have, improving quality of life of citizens by providing more reliable and efficient transport options. And then the other ones are split in between. What is your take on this? What is the main added value of having a digital twin for mobility for a city?
Well, there is a number of added values. Indeed, what you are talking about is quite complex, and not just being able to respond to the past, but better plan for the future, also short-term, but also long-term future, can have all different positive impacts. So one simple one, which I can talk about, is increased electrification. So what we have been doing is, for example, to look at which bus lines to electrify first, what type of buses are needed because of the road. Is it downhill, uphill? What kind of battery? Should we switch the battery? Where the charger should be located? What kind of charger? But also not just that, thanks to the real digital twin approach that we have, we can look at how mobility can participate in electricity market. So the buses are actually then becoming a moving set of batteries which are on board, and they can be an independent power producer participating in the market, selling in short-term market the electricity. And that is allowed by the real-time operation knowledge. We have the 15 to 20 minute stop of a bus on a last round, and it could sell and buy electricity in that time. So that is also lowering, for example, for the city, the cost of peak power or shifting the power, which have a significant impact on the grid infrastructure. So when we start to look at these systems as a combined digital twin, we can co-optimize them. Another example is the planning, long-term planning. So the mobility providers want to offer the last mile, a number of vehicles for the last mile. The question is how to provide such service and what kind of automated transportation system we need. We know the radius and what kind of vehicles are needed where. So one could imagine Uber-like service where people come to the hub and they can be matched within actually bridge-like, so shared Uber, where you have a car, even self-driving, as we also model that, bring them to a different location within the city. What should be the amount of vehicles? Where should they be located? When? So management of that dispatch of vehicles or different types of vehicles. Then there is also another aspect of new businesses. We have, for example, looked at Canton Zurich on-demand responsive transportation. One of the colleagues have been mentioning that as a project of urban delivery logistics. We have already done that, looking at short-term delivery and optimizing the amount of cars, the amount of hubs, logistic hubs, where to bring the products into the city in a most efficient way. Further, the usage of fleet. When you have the real-time data feed into the system, one can optimize the dispatch. So, for example, the buses don't have to be the same size throughout the day. As we model current and future events, we can put in an event and see how the system, where the people go effectively, so where the urban mobility is needed. So then the vehicles can be adjusted in terms of their size and also even location to provide for that service. Moreover, transport systems, as I mentioned before, are in a time span of a decade or multiple decades. So having the urban modeling capability of evolving twin, one can see how the system would change in the future, which will also have an impact on risk assessment for the investor, as the systems are often quite expensive. In terms
Anna,
of, yes.
I think you're touching a bit on the next question, which is the challenges. So I just,
right.
If I can interrupt you, thank you. And just ask maybe Hans if he can tell us, based on his experience in Vienna region, what is the main added value of having the digital twin for mobility for you guys? What has it been?
For the context of a city region, I think the goals are sustainable and safe transport. And I think we can tackle these two goals quite easily together. I think there are pull and push strategies. I think the pull strategy is to provide people with worthwhile alternatives to private cars. And that's now, so this has to be planned, and we have to provide all the information and prognosis for this planning, and then reliable service and information about these alternatives. And this comes to, in the end, to mobility as a service. And we have quite a lot of projects going on to come to this one-stop shop for all various mobility services. And I think on the other hand, there has to be push strategies that make sustainable and safe transport more and more attractive in relation to private car use. And that's going on in the Vienna area as well. And what's coming up as our new challenges is freight transportation in the city logistics. We developed a fine-graded goods transport model for the Vienna region. The software is on GitLab. And we do a lot of things with this now. And we have a lot of projects like midi hubs, mini hubs, things to load the goods on different points. So I think that will be the next big challenge in urban mobility. And all this together, it comes down to quality of life for the people in the city and to climate change. I think all that we are doing here is to increase the quality of life of the people and to induce climate change. And there are many things that we do. It has to do with planning, it has to do with information, and it has to do with traffic management, down to manage traffic lights, manage tolls, all the stuff.
Okay, thank you. That's sort of coming along, if I understood correctly, that we have also added, in addition to, let's say, quality of service and efficiency and climate change, we have also added this aspect of, let's say, providing new businesses for the city, as Anna has mentioned. I want to just quickly touch upon a question of what are some of the challenges facing the implementation of digital twin, which is our third question, because I really want to get to the fourth question, which is more, how do we see this working together? In which sort of platform do you see this? And this data that has been a question. So if we can just maybe share quickly the responses to the third question, Vanessa. The third question, as I mentioned, is the question of what is the main challenge for the digital twin in urban mobility? And the provided answers were lack of needed quality of data, access to data from different stakeholders, variation in development levels of different existing systems, low awareness of city governments about digital twin concept and benefits, and unclear benefits with high costs for development and use. And main responses that we received, at least online, I don't know if we had any responses here, but online, it was mainly the responses lack of data quality and then low awareness and unclear benefits. Can you just very quickly give me your response to this? What do you think is the main one main challenge? If you could say one main challenge for the digital twin.
Yeah, so let me start here. I think the technical challenges are all solvable. We have IE systems that are very accessible now and that bring our models in sync with reality. It's not as hard as it was. And so that's, I say, the easier task. The real challenge now is to organize cooperation of the different players. And in Austria, we have very positive experiences here. We have different models for different goals. We have long-term agreements and associations that tackle the infrastructure information. We have a partnership under civil code for the public transport institutions. We have public-public cooperations for real-time road information. And we have a limited company for the traffic and transport information because they sell services. They need this kind of extra protection. And I think this structured approach is the way to go in the twin city. We cannot have just one big body that does it because the complexity is too high. I think we have to break it down and have organizations and institutions that work together. And in Austria, that we are a small country, but it works quite well. And it's the same with technical infrastructure. We have a model for real-time transport that calculates in 1 minute because it has to be fast. And we have a model for planning purposes, and that takes a whole night to calculate. And they share a lot of properties, they share a lot of input data, but they have different goals and they have different granularities. And I think it's important to unify things, but it's also important to not mix things up.
Okay, so if I understand correctly, your response is more the main thing is to have all the stakeholders working together because it's a complex system and we all have to work together on it. Anna,
yes.
What is in your opinion the main challenge right now?
I believe the challenge is the integration. Hans has called it the challenge of stakeholders. That's a part of it, and the technical integration. I believe it's not just the data which can be shared, the structures of the coding can be shared across, and what we have is at the same time has a granularity and a scale. We do it as a scale of continent all the way down to an individual. And depending on what we need, we can go 1 second time step or decade time step. And that can be done in one system, but it has to be well done. And we have worked on it for over a decade, but it's very difficult to explain often how the benefits are of a system which allows for the long-term and short-term planning, because it's also complex. So there is a challenge of IT understanding. And so we saw that what is very important is that the interaction which is done with the system is created to be intuitive for the stakeholders to see their own benefits and their perspective. So in a way, it's one brain which requires multiple interfaces, multiple faces. And that is quite a challenging effort, that integration and translation in a way.
Well, I think that sort of brings me to the last one, which is the main thing that I really wanted to also ask you, which was the question of, on one hand, we asked people where they see, how can these different stakeholders work together technically on which sort of platform? Is it the platform that is accessible only to the users that need the data, that need the data for their business or the government? Or is it open access, let's say one platform that city governs that everybody can access? Is it sharing sort of between only the partners that are working together? Or is it an EU level platform, which we heard at the beginning from the talk, an EU platform that everybody can access and get the data? But then the question that I have for you is not this one, it's what would be the interest of different, let's say, companies or different stakeholders to share their data with the local government or with the city in order to develop the digital twin? We heard earlier somebody ask, okay, if a city has a digital twin, can I access it to add my services on top of that? So what is your opinion here?
You want to go first, Hans?
Yeah, so what I see it, we have just now, we're struggling with that in a project. There is a massive legal gap when public institutions want to cooperate with private companies at eye level. It's very hard to do that. We have a project where a lot of lawyers, a lot of things. And I think that we need maybe a legal possibility for that. I don't see it now. It's very hard to get that going. It's very easy to work together in a public context. It's quite easy to work when private companies work together. It's also easy when public institutions tender and private companies work for them, but to work together at eye level, and I think we have to come there, is quite hard to get it legally correct. And that's not an easy thing. And I think that's maybe a challenge for the future. And the other thing that I think would be necessary is that when someone collects relevant data like traffic jams about the public transport infrastructure, then that data should be shared with the sustainer of the infrastructure, with the owner of the road for free. I think that should be another rule that we should impose.
Thank you for that opinion. And now, Anna, could you please give your take on this? And very quickly, because we should be closing, even though this is really interesting.
I will try, but I agree with Hans that the legal is an challenge to be able to work on something which is future oriented, is constantly changing, and is requiring innovation. Because otherwise we don't really benefit from the digitalization capability which are evolving. So how to create not a defined purpose fully, but create a space for optimization, because these systems can be optimized. That type of a legal framework is still right now being tested in the Netherlands, but that's not an easy task. And another, maybe directly to your question, is that the data should be unified space, authorized and shared by the city, because otherwise, even if it is an open source, it's often in different areas, not coordinated, with very difficult access. So we have, for example, had that with St. Gallen. We needed to help them actually in multiple different projects collect and organize data so it can be used throughout in one framework. Another aspect here I want to say is that we believe that the data should be anonymous, and the tools for mobility shouldn't be used as tools to track individuals in every city, to be used by security agencies. And the privacy here of data is a very big topic. And from the perspective of the company here, we have a business with employees, customers, and investors. So the data sharing has to come under business plan objectives, as it is a part of our mandate.
Okay, thank you. Thank you both. We're, I think, 2 minutes over time. If we can return back to the main session, they'll want to hear some, let's say, main points from our discussion. Thank you for the very interesting discussion. It was my pleasure to have you here today. Thank you for your time. And hopefully you also enjoyed the discussion and the participants. Thanks.
Thank you very much.